Welcome to our webcast, Additive Manufacturing in the Toolroom, Engineering Office, or on the Production Floor. In today's webcast, we'll talk about how you can easily use a Rize 1 3D printer to build functional parts on demand to speed and optimize production, increase part accuracy, and slash costs. First, I'll provide just a brief overview of who we are. Then we'll talk about some common challenges using traditional manufacturing processes to produce tooling. Next, we'll cover the advantages of 3D printing versus traditional processes for many of these applications. Some of you might already be using 3D printing, but this is useful information for you if you don't use a 3D printer or if you're thinking about implementing 3D printing but really don't know that much about it. Then we'll talk about capabilities you need in a 3D printer if you plan to use it for on-demand production of functional parts in the tool room, on the production floor, or in your engineering office. I'll talk about some of Rize's advantages in this area. First, let me tell you a bit about who we are. We're a 3D printer manufacturer just outside of Boston. Rize was founded by and has a team of 3D printing pioneers with more than 20 3D printing patents to our name, including our APD technology. Rize is venture-backed. Our mission is to enable sustainable and inclusive innovation to achieve additive at scale. This means getting the technology into the hands of more users throughout the enterprise and to an entirely new segment of commercial users who haven't previously used 3D printing or additive manufacturing. So what are some of the challenges you face when manufacturing tooling, fixtures, jigs, and work holding using traditional methods? Well, it's a lot more expensive. I spoke with one customer recently who told me that producing aluminum fixtures and jigs cost him about $1,000 per part, and it took several days to weeks to get the part. The same customer also said that whenever he needed a new fixture or jig, he'd have to pull a team member off of another job to make the part. Work holding, made using traditional means, might not hold the part securely, for example, during CMM quality inspections, resulting in inconsistent parts. Your machine tool production time can be taken up manufacturing work holding fixtures. You want to reduce the number and weight of your parts. Your customers might not understand your digital models and drawings, especially for complex parts, which can ultimately result in your needing to remachine the parts at significant cost and time, and an unhappy customer. You're always looking for ways to make your quoting process more efficient and successful, resulting in increased sales. 3D printing can solve many, if not all, of those challenges. Plastic 3D printed parts are far less expensive than traditional machined parts, and some 3D printers can give you a part in your hand in a day or two. Plastic-based 3D printers can reduce the number of parts in an assembly, as well as the weight of the parts. You can use 3D printed parts to eliminate costly physical inventory by only printing what you need when you need it. Conformal work holding holds the parts more securely, ensuring they're consistent. 3D printing your tooling frees up your machine tools for production instead of producing tooling and work holding. On the sales side, 3D printing a scale or full-size version of your customer's part increases both your and their understanding of the end result. So your quoting will be more accurate and you won't have to remachine the part. Your customer will be more satisfied and you'll increase sales. But, and this is important, not all 3D printers are created equally. You wouldn't use a screwdriver to hammer in a nail, and the same principle applies to 3D printers. You need parts that will perform as well as machine tooling and work holding, so they need to have adequate strength. The printer itself can't be slow, and equally as important, the total end-to-end process of using the printer can't be slow. This includes work that needs to be done to prepare for printing and work that must be done to parts after printing. Another factor here is where the printer needs to be located. The material properties of the printed part need to interact well with your machinery and metal parts. I mentioned speed before, and ease of use is a component of speed. You don't want to have to hire specialists to run the printer or finish printed parts, and you want to spend more time running the printer and less time fixing it. In short, it needs to be as easy to learn and use as a common appliance. Just press print and get a part. In order to run the printer in your tool room, office, or on the production floor, it needs to be safe without any VOCs, and the material must also be safe for handling. Equally as important to operating your printer in any of these locations is that it can't require any messy or unsafe post-processing or part finishing after printing. It goes without saying that the printer needs to be affordable to purchase and to operate. You should also consider looking for a printer that enables you to 3D print text and images right on the parts for things like part numbers, instructions, and other such applications. So let's talk about the Rize 1 3D printer for a second. We have purpose-built Rize 1 with an appliance-like user experience to bring simplicity, safety, speed, and strength to additive manufacturing. This has never been done before. This enables you to transform your production process, redefine your customer engagement, and scale additive manufacturing across your value chain. Rize is the first ever hybrid 3D printer combining two totally different technologies into one machine. Our patented augmented polymer deposition, APD, is an inclusive multi-material 3D printing technology. APD combines two discrete technologies, material extrusion and jetting, to simultaneously extrude medical and engineering-grade thermoplastic and jet selective additives at each voxel or 3D pixel wherever they're needed to change the characteristic of the material. Here's how APD works. We extrude the layer of the thermoplastic through the proprietary extruder and then modify each layer by jetting special inks or liquids on the surface. So let's have a look. Thermoplastic is extruded, forming the support. Release ink is jetted between the support and the first layer of the part. Then thermoplastic is extruded, forming the part layers. Then special liquids are jetted between the layers of the thermoplastic to change the material properties by voxel. Rize APD process is patented and is therefore the only 3D printer that can do this. Core to our process are our materials. The filament we extrude to form the support and the part is called RIZIUM 1. It's our own compound of engineering and medical grade thermoplastic. The functional inks we are currently jetting are Release 1 and marking ink. Release 1 repels the bond between the part and the support structure. Marking ink is what gives you the ability to 3D print text and images on your parts. Given the unique nature of our hybrid process, a wide variety of materials are possible. Now let's talk about the benefits of Rize's APD technology for additive manufacturing in tool rooms, engineering offices, on the production floor, and out into the field. First, part strength suitable for functional applications. Rize 1 produces the strongest parts. They're isotropic, meaning that they have uniform strength in the X, Y, and Z axes. This means you don't have to worry about how to orient the part in your printer to produce a part that's strong enough for your application. Our parts are consistent and accurate. They have an HDT of 99C. The low rate of water absorption, less than 1%, reduces the chance of warping or coolant attack. And the parts are chemically resistant to acid, alcohol, and acetone. In fact, one of our customers uses Rize parts functionally to mix various chemicals. RIZIUM 1 is a higher performance compound than traditional ABS or PLA. Like I said, it has extremely low moisture absorption that allows for consistent output. It's also lower density than most of the typical plastics. It's compounded from the medical grade components. Here you can see that our RIZIUM 1 material has uniform mechanical properties in any direction and how that compares to a costly FDM system. Isotropic properties are important in additive manufacturing applications because you get a part that really mimics injection molded ABS part performance. You're able to conduct accurate tests to optimize your designs. You can save a lot of time and money on tooling produced with traditional manufacturing methods. And it enables you to build a custom and replacement part on demand wherever you need it. This shows the problem with 3D printed items when it comes to functional use applications. Brittleness, weakness, low HDT, low flux strength, incomplete curing, non-isotropic properties, poor finish, inaccuracy, little accuracy, that is. This video really drives home that point. See what happens with the first catapult produced on an FDM printer and the second catapult produced on a Rize 1 3D printer. The next consideration is speed. Print speed alone isn't important. What is important is the total time it takes to get a functional part in your hand. This total time to functional part involves pre-processing, printing, and post-processing or finishing parts. This graphic captures the time to functional part difference between Rize and traditional manufacturing methods, and Rize and other 3D printing technologies. You can see here that traditional manufacturing methods have several stakeholders to get to the final part. When you are iterating, that means 5 stakeholders and 3 weeks per iteration, and lots of friction between each handoff. This improves a bit with 3D printing with today's technology. You still have handoffs at each step. You have fewer steps. And so you might have, for each iteration, a few less stakeholders for a handoff. So say a little bit more than 2 days to 2 weeks, though, for each iteration. Now let's have a look at Rize's additive manufacturing process. So now we have one stakeholder, no friction between the steps because there's no handoff. It's largely automated. And so for each iteration, it's only one stakeholder and 1 day. This means that Rize is 50% faster for a third of the cost, actually, versus other 3D printers. In terms of pre-processing, our Rize software automatically prints most imperfect files, so no additional software tools are needed for file fixing in order to make the file printable. It's as fast and easy as clicking print. In fact, SOLIDWORKS users can print directly to Rize 1 with one click from within SOLIDWORKS software. On the front end, users are often faced with purchasing and using additional complex software tools to design and make a file 3D printable. That can be tedious, time-consuming, and difficult. As a result, many engineers purchase file fixing software in addition to their CAD software to alleviate this headache. But even those programs require additional time and expertise in order to get a 3D printable file. Rize solves this with our own build prep software that can accept most file formats. In addition to pre-processing, what many people don't know is that with 3D printers, there's a lot of work that users need to do after a part is 3D printed before that part is usable. In a study done by 3D printing additive manufacturing industry expert Todd Grimm, he detailed the impact of post-processing after 3D printing. He reported that it's a non-value-added operation that increases overhead. It complicates the workflow, adds expense and time. And for the 3D printing lab, it's undesirable. But if you're going to 3D print in an office environment, it's absolutely unacceptable. In his report, Todd spoke with a number of commercial users and discovered that in FDM processes, post-processing involves breakaway supports that, when broken away from the part, damage the part. It's very labor-intensive and tedious. Light sanding is also required to remove the remnants of the supports on the parts. In their soluble support process, parts need to be soaked in a corrosive agitated bath, followed by removing the support remnants from the part, rinsing, and drying. Our customers tell us that with other technology, they have to wait up to 12 hours for their models to be post-processed. This usually means a full extra day for the part to be ready to use. Here's a comparison of our process of support removal versus that of the FDM process. The same part took 25 seconds with our technology versus 3 hours with FDM. We can cut time to a functional part in your hand by 50%, cut costs, and eliminate the need for materials, equipment, facilities, and mess that have been obstacles to expanding use of the desktop machines outside of dedicated lab environments. Here's an example on the right of a breakaway method I mentioned. It took 45 minutes, not including sanding, that was needed after the supports were removed. compared to just 60 seconds for Rize support removal. And you can see here that we're removing supports from several parts in less than the time it took to remove the supports from one part with their breakaway process. Another characteristic of post-processing that Todd uncovered is the safety and environmental component. Most 3D printers require potentially hazardous or messy post-processing techniques. This means the technology must be located in specially equipped labs, separated from the engineers and others who need the parts. As a company increases its use of additive manufacturing and 3D printing, it can become a huge cost if the wrong equipment is purchased, and some companies hire people just to post-process parts. An important consideration for you is also what it takes to learn, use, and maintain the printer. Rize is without question the easiest industrial 3D printer to learn, use, and maintain. We designed it to be as easy to use as a document printer, so anyone on your existing team can get up and running and use it on a daily basis with minimal training, regardless of whether or not they've ever used a 3D printer. We provide one-click printing and no post-processing. Also important is that Rize 1 is highly reliable with very minimal maintenance, especially compared to other industrial 3D printers. Its size and the fact that it emits no VOCs, uses only safe materials, and doesn't involve any messy or chemical post-processing means you can operate it on demand at the point of consumption, in your engineering office, in your tool room, on the production floor, or out in the field. It includes some nice usability features, such as a graphical touchscreen for ease of use wherever the printer is located, automatic filament hot swap so you won't run out over the weekend or during a long build, and so you won't have excess inventory of filament sitting on your shelf. The extruder is self-maintaining, so no need to worry about blocked nozzles. The heads are also self-maintaining to ensure the printer is always ready to be used and will deliver consistent, great quality. Safety for you, your employees, and your customers is another important consideration of additive manufacturing. Rize is without question the safest 3D printer on the market. What this means is that you can operate it right in an engineer's office, in your tool room, on the production floor, or out in the field without having to worry about special venting, storage, or disposal systems. Unlike virtually every other 3D printer, Rize has no VOCs or harmful materials involved in the entire process. Our materials are recyclable and biocompatible. All of the components that make up our material are FDA approved. The printer is quiet and odorless. The Illinois Institute of Technology conducted a study showing the hazardous emissions from most 3D printers, such as styrenes, lactides, and more. This is something that most people are not aware of. Now let's talk about ink marking capability. 3D printed ink marking means that you can actually 3D print detailed text and images right on your part as part of the printing process. And the ink is inside the part so it won't wear or scratch off. Rize 1 is the only 3D printer that can produce ink marking on a functional end-use part. This capability has wide application. You can print mounting or storing instructions on the part, safety instructions, part numbers and dates, tolerances, logos, graphics, and contact information that won't rub or scratch off. The ink can be printed below the surface to highlight when a tool has wear. You can even print digitally augmented parts, a secure QR code, for example, and when you scan the QR code on the part with your smartphone, it'll bring up all sorts of information about the part or tie into whatever system you require. The ink marking feature can be used in engineering, medical, product design, and sales and marketing applications. Everyone's concerned about keeping costs down, especially small to mid-sized companies. Cost is more than the initial purchase price of the printer. Operational costs have to be considered. Rize is the most affordable industrial class 3D printer. Not only is the initial purchase price of Rize 1 a fraction of the cost of comparable systems, our operational costs are half the cost of other technologies. With Rize, you don't incur all of the hidden costs associated with post-processing that are required with other technologies. And certainly, time is money, so getting a part 2 times faster with Rize will cut costs. Rize 1 can also replace your costly physical inventory with digital inventory, save labor costs, and reduce costly machining errors. Consider this. A CNC machine tool and programmer costs around $200 an hour. They spend 5 hours a week making one piece of work holding. That's $52,000 a year. Rize 1 costs $35,000 all in. And if you add $5,000 worth of materials, you've just justified your ROI within 9 months. I just want to share with you 2 relevant customer stories. You can see additional case studies on our website if you're interested in learning more. HMS Industries, manufacturer of custom metal stamping and industrial tooling, based in Blairsville, PA. They provide high-quality manufacturing services including product and prototype development, EDM tool design, tool and die manufacturing, as well as high-volume stampings and CNC machining to manufacturers across all industries. They selected Rize 1 to produce functional jigs and fixtures for holding parts in machines during CMM quality inspections. HMS cited Rize's unique zero post-processing, isotropic part strength, ease of use, and low cost for the purchase of their first 3D printer, enabling on-demand production of custom and replacement jigs and fixtures at the point of consumption in the company's tool and die shop. Priding themselves on strict quality control standards, they needed a fast and affordable way to produce in their tool shop strong jigs and fixtures that can secure parts during production to ensure that the parts they manufacture are consistent. Previously, they built jigs and fixtures from aluminum, each costing as much as $1,000. This required a specially trained team member to be taken off another job to produce the part. With their Rize 1 3D printer, HMS employees design and print parts on demand in their tool shop in one day, freeing up a team member and saving up to 2 days per part, per fixture, producing aluminum fixtures, and versus producing aluminum fixtures, and only costing about $40 a part. Rize's safe and sustainable biocompatible materials and process without any VOCs or post-processing enables the team to operate Rize 1 in their tool shop without the need for any special ventilation, storage, or disposal equipment. They also use our breakthrough 3D printing marking capability to indicate right on the part the location where the part number should be placed and part numbers for identification. The team was able to learn how to use Rize 1 and be up and running in less than 20 minutes. Noting that a digital model can't tell the whole story, the HMS team also prints complex parts to assist in the quoting process before machining the parts. This avoids the additional time and high cost of potentially having to remachine the parts and increases customer satisfaction. In short, Rize 1 has exceeded HMS's expectations. Now we'll turn to ThermoFab. Since 1976, ThermoFab has distinguished themselves for delivering unparalleled thermoforming quality, accuracy, superior service, and an astonishingly fast 4 to 6 week turnaround for companies seeking custom plastic enclosures in small quantities. They're focused primarily on the medical, industrial, computer, and armed services markets. ThermoFab has an impressive portfolio of clients such as L3, Mako Surgical, Locus Robotics, Cisco Starry, Transmedics, Biotech, and many more. Their CEO, Tom King, believes in leading, not following. This innovative philosophy drove his interest in adopting 3D printing at ThermoFab. After observing 3D printing for a year and carefully evaluating Stratasys and Rize 3D printers, he purchased a Rize 1 3D printer due to its unique ease and speed of support removal without solvents following 3D printing. They used their Rize 3D printer to produce fixtures for setting up production rather than using blocks of CNC machined aluminum. He said they produced low volumes of enclosures for high-end equipment, producing 5 to 10 or up to hundreds of parts per month, and they have to be right. Producing aluminum blocks just took too long. ThermoFab's engineers also use Rize 1 to produce prototypes of small thermoformed parts such as faceplate backings, housings, and more for form and functional testing before manufacturing the final product. Using Rize 1 instead of CNC machining to manufacture fixtures is speeding their process at a lower cost. 3D printing saves them time by eliminating tooling errors. It's also reducing errors before expensive tooling is cut. In one case, for example, a 3D CAD model of a very large part was created from a 2D drawing, scaled down and 3D printed prior to cutting the tooling. Printing the part exposed a curve in the design that couldn't previously be detected in the actual part, averting a costly error. Tom says, "We're happy with every fixture we've made." Always innovating, they also produce experimental parts on the Rize 3D printer, testing the possibilities to continue to improve their process and expand their services. For example, they plan to use Rize 1 technology to manufacture tooling. According to Tom, the more you play, the more you learn, and the more you learn, the better you get at it. Before we wrap up, I'd like to summarize the advantages of using Rize 1 for additive manufacturing in your tool room, office, or on the production floor. Rize offers the strongest isotropic strength functional parts, the fastest on-demand production of custom replacement parts, the easiest to learn and use 3D printer. No special expertise is required. It's the safest to operate in any office, tool shop, or virtually anywhere. It's the most affordable to purchase and operate. And it provides the only ink marking capability on a functional end-use part. Rize 1 is ideal for producing welding fixtures, soldering fixtures, CMM measurement fixtures, product assembly jigs for pipe and tool manufacture, precision bench fitting operations and drilling, reaming, and tapping, for example. Rize is the logical choice for your additive manufacturing needs. I want to thank you for attending our webcast today. For more information, please visit our website at www.rize3d.com.